Fireside chat. I think you're going to really be excited about this one. We had a conversation about 4 months ago, I think, maybe it's 5 months ago. Mark, you'll have to refresh my memory, but we did a seminar as part of a program for Bain Consulting on the energy sector. And out of that, we had a conversation about a Caltech professor who had developed a new process for hydrogen. And so today we have with us two experts on green energy. We're going to talk a little bit about the implications of that, because it seems that things have developed in such a way that we may actually have some promising new approaches to scaling hydrogen energy in a way that's effective. And we've tried this before. I visited BMW's facility in Munich almost, had to be 9 years ago, and drove their hydrogen prototypes. So a lot hasn't really happened on the distribution side, and we're still using precious metals, so I'd be very interested in that conversation. So with that, why don't I ask you to kick this off?
Okay. It's late, so let's have a video. We'll hopefully wake everybody up.
Future is here, and the world needs green hydrogen to achieve its net zero carbon goals. By using renewable energy to make green hydrogen, we can utilize this zero carbon resource for low-cost, grid-scale storage and to create a sustainable fuel source for utility, heavy transportation, and industrial applications. However, we are currently unable to fully harness the Earth's abundant renewable energy resources through hydrogen because traditional electrolyzers rely on scarce and costly platinum group metals, PGMs, as catalysts. Enter H2U Technologies. We are helping scale the hydrogen economy through our new AI-powered catalyst discovery process and our groundbreaking low-cost electrolyzer designs. Developed by a team of Caltech scientists with $122 million in funding over 10 years, H2U's Catalyst Discovery Engine identifies effective non-PGM catalysts through an iterative AI-powered process. Our CDE solution tests millions of combinations and treatments of inexpensive, earth-abundant materials, identifying pixels with the most promising catalytic properties. H2U's Catalyst Discovery Engine identifies new catalysts at a rate over 1 million times faster than traditional methods. Starting with these new, low-cost, non-PGM catalysts, H2U is rethinking the entire electrolyzer design. Our inexpensive, easy-to-manufacture PEM electrolyzer will dramatically cut the cost of green hydrogen and allow for rapid scale-up of production. The newest generation of the hydrogen economy is here, and H2U Technologies is at the forefront. Let's unlock the full potential of hydrogen for our world together.
So imagine a world with no fossil fuels, no carbon emissions, and that's what green hydrogen is about. That's what we are looking to enable at H2U Technologies, because we've got an unfair advantage when it comes to catalyst discovery. And catalysts are where the magic happens in electrolyzers. And electrolyzers are the devices that produce that green hydrogen that can replace fossil fuels. I was walking over here from Palo Alto earlier and feeling the heat, and somebody said, well, it was a lot hotter last week. As we all suffer through the effects of climate change with wildfires and these other things, fossil fuels still represent about 80% of the world's energy consumption. 60% of electricity generation in this country is still fossil fuel. So we can even electrify all of that, and you still got more than 3/4 of the problem remaining, even if we were fully renewable for our electricity grid. There's still a lot of energy consumption, or what we call hard to decarbonize aspects of our economy, and globally that's true as well. So green hydrogen is a carbon-free fuel. It doesn't use any carbon when you make it, doesn't use any carbon when you burn it. You apply electrical charge, renewable electricity, across a catalyst that turns water into hydrogen and oxygen gas, and you use the hydrogen gas as a fuel. When you burn it, guess what? Makes water vapor. It's a benign cycle, and it's why I'm here with H2U Technologies.
So if we cannot control CO2 emission in the next few decades, we can convert the world into a place which may be no longer worth living in. This may be one of the most challenging and most important problems of our times. It is, as some of my colleagues have said, it's like a war-like scenario. Unless you win that war, you will go under. And not only do we have to fight this global challenge, you see another problem right now, literally on a daily basis, if you listen to the news, where one country, Russia, tries to take advantage of the Western world by taking it hostage with respect to its energy supplies. So if we can come up with a renewable world, we will be obviously much better off. The good news is there is plenty of renewable energy available. If I can have the first slide, I would like to show you. Yes, let's go to the next one. Here is the good news. The good news is when you look at this heavily log plot, where you see the energy potentially available from, or power available from renewable resources. This red arrow, which you see in the lower portion of the slide, is what mankind is using today. So you can see there's an abundance of renewable energy available in this world, and we just got to come up with cost-effective ways of utilizing it. Beginning with solar, where we have the most, second is wind, and then it goes down, but all of these are substantially more than what mankind around the world is using, everything together. So plenty of renewable energy available, and for that matter, renewable energy becomes very cost-effective too. We are in a situation where we have solar energy available even on a levelized cost of the order of less than 2 cents a kilowatt hour. Extremely attractive. It's going to be hard to match that with any fuel sources. So you see, in principle, a scenario which is extremely attractive for switching, and a lot of economic incentives for switching to renewable sources. On the next slide, you see some of the challenges. The problem with renewable energy, it is not easily dispatchable, or you cannot easily make it available 24/7. Whenever you need it, it may not be available. So what you need, the answer is you need storage. You need massive amounts of storage, as you just heard, to mitigate the fact that renewable energy fluctuates. The sun obviously shines only a few days an hour, and in some parts of the world more than in others. But the same is true for wind. It blows more in the fall and in the spring, and less during the summer and during the winter. So we got to have storage, and we're going to have massive storage. And for that purpose, there are a number of opportunities, hydrogen being a significant one. It can be very cost-effective, more cost-effective than battery, especially when you talk about time frames of the order of months or half a year, as we certainly need for a wind scenario. So without storage, a renewable world is not possible. And with that, we need to look at technology alternatives. As I said, hydrogen being a good one. As you go to the next slide, you can see that, and as you just heard, we have to first make hydrogen, green hydrogen, without involving carbon fuels, without producing CO2. That's the first thing we need to make sure, without taking any of the resources which produce in one form or another CO2. That is possible by splitting of water if they have the right technology and if it can be done in a cost-effective fashion. Then the second part is how to utilize it. And as you just heard, both is possible with modern technologies. There has been, until recently, one major challenge. Every chemical process or related to hydrogen needs what's called a catalyst. Under normal circumstances, the splitting of water or the utilization of hydrogen to make water is relatively slow, unless we let the reaction happen on a surface, on a catalytic surface. Historically, these catalytic surfaces, these metallic surfaces, which serve as these catalysts, have been made out of relatively expensive materials. In the case of making hydrogen, of an electrolyzer, it was made out of iridium. And there's a very limited supply of iridium in this world. Maybe you will comment on that. And then as far as fuel cells, it's platinum metal groups. Both are not very abundant metals on this earth. So we need to come up with methods which utilize as little as possible, or we need to come up with alternatives to these expensive materials. Just to put it in perspective, when you take a catalyst, I didn't have the data, you may have the data for an electrolyzer. I have the data for a fuel cell which converts hydrogen and oxygen back into water, and you can see the cost is in the catalyst, like 40% is of the cost of modern fuel cells are related to the expensive catalyst. So if we can address this problem cost effectively, we do some work at Stanford on the utilization, on making catalysts for fuel cells. And as you heard earlier, you will hear more about the opportunities for hydrogen generation, because you already have a catalyst which is very promising in terms of its economics. It no longer relies on expensive iridium. So if we can combine those two, we have an economic way of storing energy in the form of hydrogen. Hydrogen can also be used as a carrier. We can not only store energy, we can transport energy. Both of these scenarios are very attractive for taking advantage of renewable energy 24/7. That's what we need to go to a renewable world.
Excellent points, Fritz. In fact, I think one of the speakers earlier, Lindsay, was talking about infrastructure. Another beautiful aspect of this concept is largely you can use existing infrastructure to transport hydrogen. So you make this fuel, you make it with a clean process, and you can also transport it with much of the same infrastructure that currently exists. So you're not throwing away or recreating trillions and trillions of dollars of infrastructure. In fact, many gas companies, natural gas companies, are looking to blend hydrogen today. And without any changes, they can blend almost 5 to 10% of their mix can be hydrogen. And that's it's a huge opportunity, and it's the technology is already here.
And we have the economics on the generation side. We just need to get the economics on the storage and the transport side. If we can bring all those two together, we have a different world. And for example, very specifically, Germany would be in a different situation if they would have taken all the money they have spent during the last decades in investing in the natural gas infrastructure, buying natural gas from countries such as Russia. We would be much further ahead already.
And in fact, another point on that, you can generate hydrogen as a fuel wherever you have water. You don't have to go to some place that has it to drill underground, those precious few places on this planet where you can drill for it. You don't need that. All you need is water and renewable electricity, and you can make green hydrogen.
Shall we open up for questions? Okay.
I'm fine.
Why don't we open it up for questions?
Yeah, I want to comment on that. I will be more than glad to walk you through any details of various catalyst design, various fundamental ideas, but I'm not sure to what extent the audience may be interested in hearing about some atomistic design of catalysts.
Well, let me ask the audience one fun fact quiz question. Anyone know where iridium came from on this planet? It came from the asteroid strike, the same one that killed the dinosaurs. So hopefully we're not having any new shipments of iridium arriving on this planet soon. And if that's the case, there's only about 10% as much iridium as what you need to produce the amount of hydrogen that this planet needs. So it's an absolute scarcity, not to mention a price problem. It's 3 times as expensive as gold, and it's going to get worse.
Well, here's a question to build on that point. All right. So what happens when you eliminate the precious metals as part of the process?
That feeds right into H2U's strong suit. We have the strongest catalyst discovery capability on the planet. No one can touch what we have. It developed over 10 years of Caltech research work on what's called the catalyst discovery engine. H2U has that, and we're developing now
So I'm a layman.
PGMs.
I'm a layman, and I don't understand. I'm not a person who really digs deeply, but I'm interested in the environment. So essentially, the new process by eliminating the precious metals means we don't have to be dependent on foreign countries, United States. But 2, does it change the whole perspective of how much we can scale?
Absolutely.
And what's the cost difference?
It's the catalyst material. Thank you. You're like a good setup guy. I didn't even ask you to ask me this question, but you're great, Mike. The catalysts that we're looking at are 1/10,000th as expensive as iridium, the legacy material. Earth abundant, and in fact, we have plenty of it here in the U.S. So, in fact, we've been asked to be in the White House Production Defense Act panel because of this is a strategic value, not just to our country, but to other countries as well. So you don't have these small little pockets of materials or small little pockets of fossil fuels where you can get it and you can truly democratize the production of fuel with cheap catalysts and inexpensive electrolyzers that make the cost of green hydrogen on fossil fuel parity about the same cost as a gallon of gas, and also anyone can make it.
Same cost as a gallon of gas today.
Well, green hydrogen costs way more than that now. It's about triple. But we've got our electrolyzers. I won't get into all the math of it this hour, but suffice it to say, using our devices, our products, you can cut the cost of producing green hydrogen in less than half. And that's not even counting the production tax credit that just came in the IRA bill. So that's $3 a kilogram, which is roughly worth $3 a gallon. That'd be like someone standing next to you at the gas pump and saying, hey, would you like to use this carbon-free fuel? And I'll give you a $3 a gallon discount on it if you do that. That's what we offer.
How far do you think we are from the $1 per kilogram?
Well, with the PTC, production tax credit, we can get there now.
So,
that's a metric.
Professor, what's your observation of all this? You've been involved in this a long time. So you've seen things come and go, promising technologies maybe haven't materialized. How do you view this, what H2U is bringing to the table, or anyone like H2U on the new process? What do you think about all this?
Well,
is it promising? Is it optimistic? Is it practical?
I'm very optimistic. It just takes a will, and overcoming the inertia, we have to keep in mind we have an infrastructure which has evolved over almost centuries, certainly many decades. And getting out of that
is the tough part.
Is a tough part because it takes a mental transition from key executives and say, we're going to do that, although there may be some hurdles, some expected events may occur, and people are not necessarily willing to take the risk if they make money in alternative, in existing scenarios. Why should they bother?
Yes.
So not being aware, there's an educational component in the whole thing where we need to educate society. If you don't do it, we're all going to be doomed. Once people realize it, they will move. And there are, as I said, the key for intermediate storage is crucial to make renewable energy. And hydrogen is not the only technology.
So you're thinking about it as one key component of a much bigger platform.
That's correct. There will be certainly batteries. Yeah. Batteries today are a significant opportunity today and a big one in the future as well. They can respond to high frequency demands. Certain industry have high frequency demands. Other industry don't have these high frequency demands. And you will have a mix of technology in stationary storage, whether it's battery, hydrogen. All I'm saying from a cost point of view for long-term storage, hydrogen is extremely competitive. And what we need to do is we need to come up with the right infrastructure which can respond to the frequency needs of our industry. High frequency, lower frequency, very low frequency. And we have now a mix of technologies. All we need to embrace it. We need to deploy it. We need
And
to.
there's some promise of solid-state battery technology as well.
Solid-state battery have a significant promise for the future in terms of safety, in terms of energy density for mobile applications, power density for fast charging. There are many, many technologies emerging on the market. We just need to keep our eyes open and move. And that requires education.
So it's promising in just the nick of time, so to speak.
I do believe that's the case. At the same time, some people are already getting pessimistic that we are not moving fast enough. We are still increasing the temperature in the atmosphere, in our world, and the CO2 is still going up in the atmosphere. So unless we do something soon, it's going to be too late. So this is the time.
Well, I just read a report this morning that sea level, the ice shelf in Greenland is collapsing, and that will be about 2 feet of sea level rise at any point from now until the next 50 years. So it's an assumed event that's going to happen one way or the other. So that could be rather disappointing to us in the Bay Area to have a 2-foot sea level rise, because that would inundate a lot of the Bay Area.
It won't be pleasant for a place like Stanford.
Yeah. No, well, yes. There's all kinds of implications, including San Francisco Airport, which is a foot above the sea level. But in any event, questions from the audience?
I have a mic here. Now, I might be dating myself here, but there was in the 1990s a sense that hydrogen fuel cells were going to be kind of supersede the internal combustion engine in ways that Elon and Tesla and the battery world has kind of shifted. So I'm curious from your perspective, what didn't happen there, what went wrong, or what were the challenges there? And second, one of the big missing pieces is airline fuel. I mean, how do we get air travel green? And does green hydrogen have a way to actually power aviation? And that'd be interesting to get your reflections on that key piece that it's still kind of unsolved.
Certainly. The second question first, there's a whole line of gas turbines that are being developed by many of the large OEMs to run on hydrogen. So you're likely not going to fly a plane with batteries, but you can fly a plane with hydrogen as the fuel. And then secondarily, the reason for the belly flop back in the 90s of the hydrogen economy is that the costs were just way too high. And it was based on fuel cells and vehicles. And frankly, passenger vehicles, are not the low-hanging fruit for hydrogen. That's good domain for, I'm an energy storage guy. I've been in this space for more than 25 years. And I can tell you there are good applications and they're fringe. The sweet spot for hydrogen applications are what we call the hard to decarbonize aspects of the economy. So think of that as steel mills, think of that as cement, think about that as heavy trucking, aviation. Those are areas where you don't have a lot of good alternatives to fossil fuels except for hydrogen.
Yeah, I would like to comment on what you said regarding the early 90s. At that time, there was a big discussion, should we go fuel cells or should we go batteries? And it turns out that for mobile applications, particularly for cars, the batteries have won. And there are a number of reasons, because in a fuel cell vehicle, as in a car, it has some challenges in terms of system complexity. When you're a fuel cell car, you need a fuel cell, you need a sizable battery, you need a humidification system, and you need a cooling system. So you have a fair amount of system complexity, and in addition, you need to have the hydrogen storage. Pressurized tanks, which are as expensive as the fuel cells themselves. And when you go for stationary applications or for larger mobile applications, that problem gets substantially simpler because you don't need that high of a pressurized tank, which again is a very expensive proposition.
Well, I want to thank both of you for an informative presentation and discussion with our audience. So thank you very much.
Thank you all for hanging in there.
Yes, thank you.
Clark, thanks, Mike.